Hello and welcome to this look at an unstructured boiling points and intermolecular forces question. So it gives you a table with some boiling point data for ammonia, fluorine and bromine. It also gives you the formula for each one so you can visualize the atoms that are present. So explain the different boiling points of the three molecules is what they want you to do, and also to include the names of any relevant forces and particles. So essentially what you're trying to do is relate the energy needed to overcome the intermolecular forces present to the boiling points listed. So in terms of the main intermolecular forces influencing boiling point, ammonia will have hydrogen bonds and both fluorine and bromine will have London forces only. So obviously there's a large difference between the fluorine and the bromine being 59 and the fluorine being minus 188. So considering that technically they have the same intermolecular force in action, what's going on here? We've got to go back to the size of the actual molecule. Now, in terms of the size of the molecule, they both have 2 atoms per molecule, they're being diatomic. So we need to go even further. We need to look at the number of electrons that each molecule has, including the inner shell electrons. So to do this, we go right back to the periodic table, and we remember that protons equals electrons in each atom. So if we take the relevant 2 parts of the periodic table, the box for fluorine and the box for ammonia, and look at the key on the periodic table, it says the atomic number, which is obviously the same as the proton number. For fluorine it's 9, and for bromine it's 35. So considering you've got 2 fluorine atoms in F2, you multiply 9 by 2. And you've got 2 bromine atoms in Br2, so you multiply 35 times 2. So that gives us 18 electrons in a fluorine molecule and 70 electrons in a bromine molecule. Quite a large difference. And going back to our intermolecular forces ideas, more electrons means more and stronger London forces. So now we've done some thinking, we can pull it together to structure our answer. So the relevant forces and particles, I've highlighted them in pink for you. So ammonia has hydrogen bonds between molecules, and fluorine and bromine both have London forces between molecules. Now we tackle the boiling point explanation part. So in general, hydrogen bonds are considered stronger intermolecular forces than London forces. So we can state that hydrogen bonds in ammonia are stronger than London forces, so require more energy to overcome. Hence the boiling point of ammonia is greater than that of fluorine. Now coming back to bromine, it's got many more electrons as we've just deduced than fluorine, so the London forces in bromine are stronger than those in fluorine. So the London forces in bromine are stronger, so much so that they actually end up being stronger than the hydrogen bonds in ammonia, because there's just simply so many of them. So collectively, the force they exert, the force of attraction between one bromine molecule and a neighbouring bromine molecule, is actually stronger than the force of attraction that's exerted through hydrogen bonding between 2 neighbouring ammonia molecules. This final point is actually quite difficult to pin down, which makes this question challenging. So hopefully it's been a useful look for you at how you might deal with not just an unstructured question, but one that really points down into a tricky piece of deduction. So as always, thanks for listening. Until next time, see you soon.